All right, so I'm going to work through those Trig review word problems. So if there's any that you struggled with, just scroll to that one or fast forward to that one and watch what you need. So the first problem says a ship is on the surface of the water. Here's the ship. And its radar detects a submarine at a distance of 238 feet at an angle of depression of 23 degrees. How deep underwater is the submarine? Round your answer to the nearest whole foot. All right, so we have a submarine over here, and then this ship is using a radar to detect that ship, and it is 238 feet away. All right, what we also know is that this angle right here, so an angle of depression is from the horizontal down. That angle is 23 degrees. All right, so you can kind of see that if we drop the vertical and the horizontal here, we have a right triangle. And we're trying to find how deep underwater the submarine is, so we're actually trying to find that. So it turns out that in this situation, if this angle here is 23 degrees, turns out this one is as well. We call those alternate interior angles. But that's just due to the fact that we have some parallel lines, and then that red line is called the transversal, and it creates some angle pairs. But anywho, so if we look at the situation that we've got going on here, this x right here is opposite the 23 degrees. This is our hypotenuse, and if you think of SOHCAHTOA, we know that if we have a relationship with the opposite and hypotenuse, we can say the sine of that angle, which is 23 degrees, is equal to our opposite x over our hypotenuse of 238. So to get x by itself, we're just going to multiply both sides by 238. So grab your calculator, make sure you are in degree mode, and if we go ahead and plug in 238 sine of 23, we end up with about 93 whole feet. So 93 is our x. All right, and when you enter this stuff in the Google form, just make sure you don't label it as feet, otherwise you will not get the right answer. So you just plug in 93 there. All right, the second problem says two observers on the ground are looking up at the top of the same tree from two different points on the horizontal ground. The first observer, who is 83 feet away from the base of the tree, looks up at an angle of elevation of 58 degrees. All right, so let me draw what we've got so far here. So we've got this tree over here. We have one observer who is, it says, 83 feet away. So this whole distance is going to be 83. And we're assuming the ground is horizontal. And he's looking up at the top of the tree at, that's not really the top, at an angle of elevation of 58 degrees. The second observer is standing only 46 feet from the base of the tree. So he is quite a bit closer. So here's the second observer. And he's also looking up at the top of the tree. And he is 46 feet away. At what angle of elevation must the second observer look up to see the top of the tree? Round answers to the nearest tenth of a degree. All right, so in order to figure this out, we want to figure out that angle right there, so we'll call that theta. We don't have enough information because in order to find theta, we need to know two sides in this smaller right triangle. So I'm actually going to start with this larger right triangle because I have an angle and I have a side, so I can find this height of this tree, which we'll call x, and then once I have x, I can use that to find theta. So if we look at the highlighted triangle there, we have x is opposite the 58 degrees. This 83 feet is adjacent, so if we have opposite and adjacent, think TOA, so that's tangent of 58 degrees is equal to our opposite x, over our adjacent 83. So again, we're trying to solve for x, multiplied by 83. These guys cancel. And then if you plug in 83 tangent of 58 degrees, you end up with about 132.8. So now that we know x right here, now we're going to look at this smaller triangle. So let me grab a different color here. And in this smaller triangle, we still have x is opposite. Now we know how long that is. 46 is adjacent, but now we don't know theta. So we're going to say the tangent of theta is equal to our opposite, which is 132.8, over our adjacent, which is 46. And we want to get tangent by itself, so we're going to have to do the inverse tangent to get theta by itself. And at this time, you can grab your calculator, go ahead and plug in tangent inverse of 132.8 divided by 46, and you get about 70.9 degrees. So theta is 70.9 degrees. So that's how far up that second observer would have to look to see the top of the tree. All right, the next one is a little bit of error analysis. It says, consider the following problem, which Stephanie and Adam are both trying to solve. A cat who has climbed a tree looks down at a dog at an angle of at a 28-degree angle of depression. If the dog is 34 meters from the base of the tree, how high up is the cat? The first steps of their work are shown below. Analyze their work and determine who, if anyone, has set it up correctly. All right, so remember an angle of depression is if you're looking straight out and then down at 28 degrees. So I can already tell Stephanie is wrong. She put the 28 degrees inside, and that angle doesn't mean anything to us. It's not an angle of elevation. It's not an angle of depression. She just way off the mark. So Stephanie is wrong, so I'm just going to cross that option out. And then let's look at Adam's work. So this cat is looking straight out and then down at a 28-degree angle to the dog. So this is kind of like the first problem we looked at with the submarine. These angles are, in fact, equal because they're, again, alternate interior angles is what we call those. So if we look at Adam's work, he's saying the tangent of 28 degrees is equal to, we're trying to find the height of the tree, or the height of the cat in the tree. So that's opposite the 28 degrees, 34 is adjacent. So it makes sense that we would use tangent, and we have opposite over adjacent. So Adam is right. So that is our right answer there. So now that we know Adam's right, we're going to solve that equation to find out how high up in the tree is the cat. So we already know what the setup is. It's tangent of 28 degrees equals x over 34. And we need to get x by itself, so go ahead and multiply both sides by 34. Those cancel. And plug in 34 tangent of 28 degrees. And we get about 18.1 if we round that to the nearest tenth of a meter. All right. So next we're going to get into those challenging questions, and these are pretty tough. So if these were the ones you've struggled with, I understand they are difficult. The first one says a person starts out 17 miles from the base of a tall mountain and looks up at a 4-degree angle of elevation to the top of the mountain. When they move 12 miles closer to the base of the mountain, what will their angle of elevation be when they look to the top? Answer to the nearest degree. All right, so I'm not going to draw this very beautifully, but that's okay. Over here we have a mountain. Over here we have some person, and they are 12 miles away. Oh, 17 miles. Pretty far. All right, so we got 17 miles, and if they look up to the top of this mountain, a very big angle of elevation. It's 4 degrees. So then they're going to move 12 miles closer, and that's going to get them to about there. And they look up again. And now, this is actually what we want to find. We want to figure out, well, now what's their angle of elevation to look up to the top. All right, so we know a couple things. If this, here they started here, they moved 12 miles closer, so this is 12. And we know this entire distance that they start with is 17, so that has to be 5. And we're going to assume this is a right angle here, like usual. So this is going to end up being very similar to what we did in that tree problem. That was the second problem. First, we're going to find the height of the mountain, which I'm going to call x. And we are going to do that by using the larger right triangle here, since we know more about that. I don't know if you can hear that running around, but my cats are being absolutely bonkers right now. So if you can hear a bunch of running around, that's them. Okay, anyway, I got distracted. We're going to find x, so notice that x right here is opposite the 4 degrees. This 17 is adjacent to 4 degrees, so that tells us we're going to say tangent of 4 degrees equals x over 17. Go ahead and multiply by 17. We get 17 tangent of 4 degrees is about 1.2. I'm going to say 1.19 just because we're not done yet. And remember, that's in miles, which, I mean, it's a mountain. That's still a pretty tall mountain. So now that we know x, I'm just going to write this in here, 1.19. We're going to look at this smaller triangle. So we've got two sides. X is opposite. 5 is adjacent. So now we can find theta. We're going to say tangent of theta is equal to x, which is 1.19 over 5. And just like in that previous problem, to get theta by itself, we're going to take the tangent inverse. Those cancel. And theta is going to be the tangent inverse of that fraction. So let me plug that in here. Tangent inverse of 1.19 divided by 5. And we want to round to the nearest degree. So I get like 13.3. So the nearest whole degree would be 13 degrees. All right. And when you plug this in, just put 13. Don't plug degrees in there, otherwise it won't work. All right. Now the last two, these were definitely the trickiest. I think this one right here is probably the hardest out of all of these. So let's look at it. An observer on the ground looks up to the top of a building at an angle of elevation of 30 degrees. So, oops, that's this angle right here. After moving 50 feet closer, the angle of elevation is now 40 degrees. What is the height of the building? Round your answer to the nearest whole foot. And again, do not label answer as feet. All right, so we did one problem like this back in chapter 6, but these are tough. So we're going to split this up into two triangles like we usually do. And we're going to look at this larger one with the 30-degree angle in there. And notice we don't know either side. We know this entire side is 50 plus x. And then we know this side here is y. So we still have opposite and we have adjacent. So we're still going to use tangent. We're going to say the tangent of 30 degrees is equal to y over 50 plus x. And that's all we can do for now. So now I'm going to use this 40-degree angle, and I'm going to look at this smaller right triangle right here. So for that one, we're just going to set up a different equation. We're going to say the tangent of 40 degrees is equal to, our opposite is y, our adjacent is x. All right, now notice we have two equations with two variables, which we can solve this. So in order to figure out what this equals, we're going to have to do some algebra now. So what I notice is that it's going to be pretty painless to get both of these equations solved for y. So on this side, I'm going to multiply by 50 plus x, and I'm going to multiply this side by 50 plus x. Because if I do that, those two quantities cancel out. And then we're just going to work from here. We're going to simplify this a little bit. So if we distribute this tangent 30 into this factor 50 plus x, tangent of 30 degrees times 50 is going to give you, if you throw that in your calculator, about 28.8, I'm going to say 87. All right, and you really don't need too many decimals here since we're rounding to the nearest whole foot. 2 decimals will be fine. And then tangent of 30 times x is going to be about 0.58. You plug in tangent of 30, so 0.58x. And that equals y. All right, so for now I'm just going to stop. And I'm going to do something really similar over here. I'm going to multiply both sides by x to get y by itself. Again, these cancel. And if we plug tangent of 40 degrees in your calculator, you'll get about 0.84. So this is about 0.84 times x. And now, since these both equal y, like this is y, that means you can set this side equal to this side. So what we're going to say is 28.87 plus 0.58x is equal to 0.84x. And then from here, it's just algebra. This is just a two-step equation with decimals. So we're going to solve this like we normally would. Subtract our x's, get those on one side. So I'm going to go ahead and subtract 0.58x. So if we do 0.84 minus 0.58, over on this side we end up with 0.26x. Over here we have 28.87. And then the last step is we can just divide by 0.26. So these will cancel here. And then if you plug 28.87 divided by 0.26 in your calculator, it looks like you're going to get about 111 feet. And I probably shouldn't have rounded quite so much because I think on the key it's at 110. So I probably should have left more decimals here. When I did the first time, I left 4 decimal places. So I will add 111 as a correct answer. So if you did say 111, I'll still give you credit on it. So that is our x. All right, but we're actually not quite done. So now we know this is 111 feet. We're actually trying to find the height of the building. So actually I don't need to change the answer quite yet because we're not done. We got to find y. So I'm going to do that in purple. All right, remember up here where we said tangent of 40 is y over x? Well, now we know x is 111. So we're going to say tangent of 40 degrees equals y over, remember we know x is now 111. All right, so if we multiply both sides by 111 and throw that in our calculator, we'll do 111 tangent of 40, and we get 93 degrees, or 93 feet as our y. And again, you can just throw 93 in as your answer. You don't need to put units on that. In fact, if you do put units on it, it'll tell you you're wrong. All right, so hopefully that helped out with that problem. The very last one we'll look at now. All right, so it says 2 observers located at points A and B in the diagram, so we have an observer here at A, and one down here at B, are watching a climber on the opposite face of a chasm. I don't know if I'm saying that right, but that's okay. The chasm is 81 feet wide. When observer A looks down to the bottom of the opposite wall of the chasm, he must look down at an angle of depression of 51 degrees. All right, there's a lot of information there, but anyway, so we know this is 81 feet wide. They already put that on the picture for us. They didn't put this on the picture, but for observer A, if they look down here to the bottom of the opposite wall, this angle here, so this purple angle that I have, is 51 degrees. All right. However, observer A sees the climber at an angle of depression of 20 degrees. All right, well, I'm going to erase this then. So just this portion here, from the horizontal to this hiker here, that's 20 degrees. And if this whole angle is 51, we can just say that this right here, this little sliver here, is 31 degrees. And I know that because the entire angle is 51. 20 degrees plus 31 degrees is 51 degrees. All right, then they tell us observer B will see the climber at what angle of elevation? So I'm going to do this in a different color. We'll do this in red. We're trying to find this angle of elevation. We'll call theta. All right, so we don't really have much information to go off of yet here, but here's what I'm seeing. I need to find a side in this right triangle right here in order to figure out theta. Because if I only have one side, I'm not going to be able to go anywhere with this. So I'm going to work with what I've got going on for angle A, or observer A, first. I'm going to highlight this. So let's use yellow. I'm looking at this right here. Okay, where I've got these two right triangles split up. And I'm going to draw those separately because, whoopsies, there's a little too much going on here. I don't know what happened there. Fabulous, it all just erased. You're going to have to give me a moment to redraw that because I don't know, Smart Notebook decided to be not so smart for a second. So, how was your day? Hopefully good. Just redrawing that stuff. Hopefully you can go outside today. It's supposed to be warm. Well, I don't know when you're watching this. I am creating this on Tuesday, March 24th. Alright, so this was 21 degrees. Just kidding. This was 20 degrees. And this was 31 degrees. Alright, did it. Okay, so this is where I was getting at. We're going to use these two right triangles that are created from the 20 degree and the 31 degree. And again, we're trying to find this angle here. All right. So we also know this up here is to be 81. Here's what I'm going to start with. Let's just do it. I've got point A here, and then I've got the horizontal of 81 feet, and then we got this little hiker dude here, and then we've got this right triangle, and this was the 20 degree angle here. All right, we can find this. I'm going to call this right here X. Because this is a right triangle, we have an angle, we have an opposite side, we have an adjacent side. So I'm going to say tangent of 20 degrees equals x over 81. Right, so we know the drill, multiply both sides by 81, plug it in your calculator, 81 tangent 20, oh man, I typed it in wrong, gives us 29.48. All right, so that's the distance here. And then I'm going to do the same thing with the 51 degree angle. So I'm looking at this big boy here. All right, so I'm going to redraw that. Actually, I'm going to cheat because I can. I'm going to take this. There it is. Ta-da. Okay. And this is 51 degrees, that entire angle. It's the right angle. And we know this is still 81. And we're going to call this y. Let's solve that. Same setup, still opposite and adjacent. So tangent of 51 degrees is y over 81. Multiply by 81. Throw it in your calculator. 81 tangent of 51 is about 100.03. And that's y. So if we look at the triangle that I drew, that means this whole thing right here is 100.03. So what I'm trying to get at is I want to know a side in this triangle. I don't have that yet, but I can find it because I know the whole, like the height of this chasm is 100.03. From this point to the climber is 29.48. So to find this, I'm going to do 100.03 and subtract the 29.48. And that will give me 70.55. All right, so we're almost to where we need to be. Now that I know this is 70.55, I can find theta because I have opposite and I know the adjacent is here, 81 feet. So I'm going to say tangent of theta equals opposite, 70.55, or adjacent, 81. Go ahead and do the tangent inverse. And these cancel, and we'll get theta is tangent inverse of 70.55 divided by 81 gives us about 40, what are we rounding to? The nearest whole degree, so 41 degrees. And again, don't label your answer as degrees when you plug it into the Google form, otherwise it'll tell you it's wrong. But I hope that helped. If you still have questions or if you're still not sure with what I did in these problems, you let me know. I can try to clarify. Just send me an email or whatever you need to contact me. All right, we'll see you guys later. Have a good day.